they've got the parasite in their gut to break it down. How does a termite destroy a house? They've got the parasite in their gut to break it down. We don't. It's kind of cool. Carbs. Gotta love them. We need the carbs, the sugars, these carbon chains. We need them in our bodies because sugars are going to be a part of RNA, ATP, DNA. We're going to take in our diet sugars that are going to help us with creating energy for the body. Glucose is going to be the most used, okay? Everything else, the body's going to have to alter, but glucose is, of course, going to be the smallest and the one that can cross into the cells rather easily. If we take in more glucose than the body needs, the body will do short-term storage. Other than that, if we don't use it within a day or two, it's going to store it in our fat cells. People who do like marathon running and that sort of thing, you might hear them talk about carb loading for like 3 days before the race. And what they're doing is they're getting that, I don't know if they're eating pasta, okay? The body will break it down and short-term storage that glucose in the muscle cells and the liver cells and make it readily available as they're running the race. Now, if we just carb load for 3 days and don't go run that race, that stuff's going to get stored in fat. Okay? But this is our energy for the cells. Now the lipids, the second source where we want the body to get energy. Now think about this for a second, okay? We are going to take in fats, all right? We take in fats in the form of triglycerides. Where in our body does something with fats become important in our body? Can you think of anything in the body at the cellular level that's going to become important?
The cholesterol in your cellular membrane.
We're going to have cholesterol in that cellular membrane, which helps to give it structure. Okay? Can you think of anything else that is important at the cellular level with fat in it? My phospholipid bilayer. Now here's what the body needs to do. We're going to take in our fats with 3 tails. But how many tails do we make? 2. So the body is going to have to convert it. We are going to use lipids for protection, insulation, energy sources. We take it in the form of triglycerides, which means we've got a glycerol head, think of like an alcohol head, and then we've got fatty acid tails, okay? And triglycerides are what we're going to take in our diet. Now, What do you associate with when you hear the term triglycerides? Go to the doctor, they like to do the blood work, then they like to tell you, you need to be on a low-fat diet. Your triglycerides are too high, your cholesterol's too high. Y'all are probably too young for that, don't worry. Okay? This is meaning you're taking in a little too much of the fats and stuff, sugars and so forth, in your diet. They want you to cut it out. Okay? Now, when we take in the fats, I'm sure you guys have heard about it being a saturated fat, unsaturated, and then trans fat. Have y'all heard of that?
They don't really put it in stuff.
Don't really put what?
Trans fat. Like a lot of products that used to use trans fat, they try to
Sure.
replace it with other stuff.
They rename this really bad.
They just simply,
Rename it.
they'll rename it or they'll just make it go bye-bye while it's still there, because we don't have any strict guidelines from FDA about labeling of our foods. So, what do they mean? If they tell you this is a saturated fat, what are they telling you? Do you have any idea? If they tell you this is a unsaturated fat, do you have any idea what they're telling you?
Bonds. Unsaturated, more of the bonds. So saturated's full, so it can't really.
How do you know that? Reading?
The carbons and the
Okay.
hydrogens are like.
But without that knowledge,
Well, saturated means like it's full, like full of fat.
okay, so you're thinking full based on the term saturated,
Unsaturated would just be like not
not
full
full.
of, like it's not full of fat. Yeah.
Okay? But then, did you know what they were telling you when they told you stuff about no trans fat? You see all these commercials? No trans fat.
Trans fat's bad.
That's all they tell us, right? Why? What is it? What does it mean?
Oxygen.
Now, here's what they're telling you. A saturated fat is telling you, now remember, these are molecules that have carbon to hydrogen bonds, all right? Meaning loaded with energy, okay? If it is saturated, every carbon is holding as many hydrogens as possible. These are going to be the solids at room temperature. Butter, lard, the good stuff. Okay? Now, if they're telling you unsaturated, along the carbon-hydrogen chain, there are double bonds, and the carbon does not hold as many hydrogens as it can. Those tend to be a liquid at room temperature. Think of corn oil, vegetable oil, sunflower oil, all right? Now the trans fat, what they're telling you is when you look at that fatty acid, when you look at the makeup of that molecule, if something is trans, it is flipped. So the molecule is exactly the same, except it's like looking in a mirror. And that is bad. Okay? Think of margarine. How many of you in here choose margarine over butter?
Because of the price.
Well, not good.
I know.
The trans fats, even though, now unsaturated, yeah, okay, But saturated, okay, yeah, okay. Definite cardiovascular risk because it's going to build up in the arteries, create the little plaques and all that sort of fun stuff, and it's not good for you. So our body needs to take in the fats because we do need them, okay? You need a certain amount of fats in your body. But guess what? Only about a tablespoon a day is what you need. I know, it just doesn't seem right, does it? Okay? Because our body, the biggest reason that we're going to need the fats is for our body to make phospholipids. Phospholipids make up the double layer of the cell membranes as well as organelle membranes and the membrane around like stuff such as the red blood cell. So it's very important for the body to get the lipids. Phospholipids have the phosphate head, the lipid tails. Their structure becomes one where the tails point inward, the heads point towards the water environments, all right? And they are going to be extremely important in the functioning of a cell. And cell membranes have to be, maybe I should just say membranes, because it's more than just a cell, okay? They have to constantly be produced. So our body has to take in the fats, break them down in those little component parts, get them to the cells. The cells will then utilize them for any way that they're needed. Now, when we talk about lipids, this material right here, all right, which is going to be clotting factors. Now, what do I mean by a clotting factor? Clotting what? Blood. Okay? These are going to be regulatory molecules. I've put them in right here because in part 2, these are going to come back to you. You're going to have the eicosanoids come back to you in the chapter on blood. Okay? Now, something else that we have to think about with the fats. In our body, we've got these lovely, lovely little cells called adipose cells. The fat cells, where it all gets stored. All right? Yay! Okay, gotta love them. All right? Now, it serves more than just thinking about cushioning and storage and that sort of thing. In our diets, as well as supplements that we can take, some of these materials that we take in, we have to make sure that the body gets them to use them. But we have the materials that are water soluble, and then we have the ones that are fat soluble vitamins. The reason I mention this is because with the fat soluble vitamins, if you take too much, it can actually get stored in the fat cells and it becomes toxic to the body. So vitamins and minerals are good, okay, but you know, knowing the right amounts and so forth, that can get a little tricky for the body. knowing how to take them, when to take them, that sort of thing. The water-soluble